In this video, we're going to be doing a Unit 5 rotational motion practice. A solid disc, mass 2 kilograms, radius 0.5 meters, rotates about its center with an angular speed of 4 rad per second. What is its rotational kinetic energy? And the radius is equal to 0.5 meters. So K is equal to inertia, 1/2 of that, omega squared. So for a solid disk, we have 1/2 mr squared. So this is going to be 1/2 times 2 times 0.5 squared, and this is equal to 0.25 kilograms times meters squared. So your rotational energy is just taking your inertia of the disk and substituting in the rest of your values. That's equal to 2 joules. A torque of 10 newtons times meters is applied to a wheel with a moment of inertia of 2 kilograms times meters squared. What is the angular acceleration? So we have Newton's second law, which is F is equal to ma. But here we have rotational motion. So you need the rotational equivalent, which is torque is equal to I times alpha. If you solve for alpha, you have that alpha is equal to torque over I. So that's 10 over 2, which is 5 rad per second squared, which is B. A hoop and a solid disc roll down an incline without slipping, which reaches the bottom first. So for this question, you need to look at your rolling energy. And you have a hoop. And you have a solid disc. So your solid disc is going to be like this. Hoop is going to be like that. We want to know which one reaches the ground first. You have to examine your inertias. So you have K is equal to 1/2 mv squared at the bottom. So E final is going to be all kinetic energy. So that's going to be K translational and K rotational. So you need to look at your 1/2 mv squared plus your I times 1/2 omega squared. So for the disc and the wheel, and for the hoop, so this for the hoop is equal to mr squared, and for the disc it's equal to 1/2 mr squared. So then we see that the hoop has a larger I, moment of inertia, and if it has a larger I, we see that this is the part that contains I. So let's say for our inertia of the disc, we see if there is a larger, let's say here, this side is the side that contains I. So if you increase your I, that means that you have a larger K rotational. More energy is going to go into rotation. So if you have a larger K rotational, that means that you have to have a smaller K translational. And you can do another version where if you have a large K translational, that would mean you have a small K rotational, because, for example, you can only have one of them that's large. Only one is large. Like if you look at 2 times 4 is equal to 8, and you still want to have something equal to 8, but let's change the first number to something larger. You have to decrease the second number. So they both can't be large. One of them has to be smaller if we want to maintain our total energy, because you have to have your conservation of energy. So that means that our disk is going to reach the ground first, because when you have a larger eye with your hoop, that means that more energy is going into rotation, so you have less translational speed. So that means that on the other hand, we're going to have the inertia of the disk. It has a smaller eye, so that means that the disk is going to reach the bottom first. So now a 3 kilogram mass is attached 0.5 meters from the axis and rotates 6 rad per second. What is the rotational kinetic energy? So we're going to treat this mass as a point mass, and that's going to be I is equal to mr squared for a point mass. So we'll compute the inertia, which is going to be 3 times 0.5 squared. So that's going to be equal to 0.75 kilograms times meters squared. Now that you have I, you can now find the K rotational. So that's going to be 1/2 I omega squared. That's 1/2 of 0.75 times 6 squared. And that's going to be 13.5 joules, which is B. Now for number 5, we have a force of 8 newtons is applied perpendicular to a 0.25 meter wrench. What is the torque that is produced? So it's going to be perpendicular, and this force is 8 newtons. We need to know what the torque is. If it's perpendicular, then we know that in torque is equal to FR sine theta. We know we have sine of 90. And when you have sine of 90, that's equal to 1. So that means that if we find our torque now, torque is equal to R, and we have our pivot as the wrench, because our pivot as the end, because when you have a wrench, it's screwed around the, you put the wrench on the screw and you put your force at the very end. Say this is the end even. Let's redraw this. It's at the very end. That's where the person's hand is. So that means that lever arm R is equal to the length of the wrench. So we'll say 0.25 times 8. And that's equal to 2 newtons times meters, which is equal to option B. Now for our next question. A solid sphere rolls without slipping. What fraction of total kinetic energy is going to be rotational? So for this question, this answer option is not listed. So the answer option here, we're going to change 2/7 to be 2/5 to be 2/7. That's going to be the answer here. And let's see how we get this. So our total kinetic energy here, we have rolling without slipping. So that means you have both translational kinetic energy and rotational. So here you're going to write that out. So (1/2 I omega squared). So when you have a sphere, you have 2/5 mr squared, and when you have rolling, you have a condition where V is equal to omega R. If we want to find omega, you can divide both sides by R. So omega is equal to V over R. Now that you have both of these, you can substitute these in. So I is equal to this, and omega is equal to this. So now you have, for your rotational, 1/2 2/5 mr squared times v squared over r squared, because that's squared. And we can see here that you have r squared cancel out, and you can multiply. So you have 2, and then you have 10 at the bottom. So you have 1/2 mv squared is plus 2/10 mr squared, or mv squared, I mean. So that's going to equal to 1/2 mv squared plus 2/5, or 1/5 mv squared, because you can divide 2 by 2 is 1, and 10/2 is 5. So now our total kinetic energy, you can rewrite 1/2 is with a common denominator of 10. So we're going to do that here. So 1/2 is equal to 5/10. And 1/5 with a denominator of 10, that's going to be 2/10 mv squared. So that's going to be 7/10 mv squared for your kinetic energy total. Now we want to take the ratio of this so we can find how much is rotational out of the total kinetic energy. So rotational is going to be 1/5, and our total is going to be equal to 7/10. The reason why you can see that is because here for rotational, you see that rotational has a fraction of 1/5, and you can see that our total has a fraction coefficient of 7/10. So you take the ratio of that, you can multiply 1/5 times 10/7. That's going to be you have 1/5 times 7/10. So this is going to be equal to 2/7. Because you have 1/5 times 10/7, that's equal to 10/35. You can divide that by 5, and that's where you get 2/7. So that's going to be option B. A wheel slows from 10 rad per second to rest in 5 seconds under constant angular acceleration. What is the magnitude of the angular acceleration? So we have our wheel here. It's initially 10 rad per second, and it goes to rest. And your time is 5 seconds. Constant acceleration, you can use cake. So we want angular acceleration. What relates these three variables? We have omega f is equal to omega initial plus alpha t. We know that it goes to rest, so this is going to be 10 plus alpha times 5, and you can subtract 10. Now it's going to be -10 is equal to 5 times alpha. You can divide both sides by 5. Alpha is equal to -2 rad per second squared, but we want the magnitude of alpha, so that's going to be 2 rad per second squared, which is option B. A point mass moves in a circle of radius 2 with speed of 3 meters per second. What is the angular speed? So we have V is equal to r omega. Angular speed, you can divide by r. Omega is equal to V over r. So omega is equal to 3/2, which is 1.5 rad per second. Rad per second, because omega is rad per second. So that's A. Two objects have the same mass, but one has a larger radius. Which one has a greater moment of inertia? So in I is equal to mr squared for a point mass, we can see if we examine what the relationship is proportionally, it's I is proportional to mr squared. So that means that if you have a large radius, that's going to mean your mass is far from your axis. And because it's going to be r squared, that's going to mean you have a much larger inertia. So if you have inertia of something, then your radius is going to be squared. So that means that it's going to be a lot larger. So that means that if you have a large radius, that means you have a large moment of inertia, because they're directly proportional. So it's going to be B. A disk initially at rest has constant acceleration 2 rad per second squared. What is the angular velocity after 4 seconds? So we can use your cake equation, which is omega f is equal to omega initial plus alpha t. So here, if it's initially at rest, that's initially 0. So omega f is equal to 0 plus alpha t. And alpha here is going to be 2. And our time interval is 4. So that's just 8 rad per second.